I am B.M. Vyas from Yadav Measurements, Udaipur. We are a test and calibration laboratory specializing in power and energy measurement. And we do a lot of testing of electricity meters, and we have the facility, one of the best facility for energy measurements. Just to give you a feel of that, we can measure energy with an accuracy of 70 ppm in our laboratory. We do a lot of on-site testing of electricity meters throughout India. We have tested about 30 lakhs of electricity meters, doors-to-door electricity meter testing. We all recognize importance of electricity in our life. And I will talk about smart grid. All of you might have heard about this and how it is important for semiconductor industry and standardization. My earlier speaker have already talked about this innovation and standards. I will give you just a brief glimpse of what is happening in energy industry. This is just an example of standards for electricity meters, solid state electricity meters, which were introduced in India somewhere in 1985-87. So what has happened here for electricity meters also is the standardization process has been lagging compared to the availability of the technology. Still, we have BIS standards which are mandatory. BIS standards for electricity meters are one of the standards which are mandatory, means there is a government regulations that no electricity meter can be sold without BIS mark. But that BIS standard is actually published in 1999 and reaffirmed in 2004 and is quite old in terms of its requirement. Just to give you one of the example is electromagnetic high frequency immunity test requires testing only up to 1000 megahertz, 1 gigahertz, while we all know that there is a lot of field beyond that frequency levels around electricity meters also. And this revision is in process. So standards has to be leading, which will help the industry. Talking about smart grid, what is smart grid? The present grid, all of us know what is the status of present grid. In smart grid or the grid of the future, what we need is better observability, better controllability, so that better services and better energy can be provided. Full interoperability, that is the requirement for the standardization. And because the technology is changing at very fast rate, so whatever investment is done has to be secured in long term. So there is an innovation, but the innovation and the implementation should be such that the investment which is made now does not become obsolete immediately after say 4 years or 5 years. So there has to be an upgradability. So it all requires strong standardization. Without this, various types of manufacturers, various technologies, as we will see further in slides, needs to be integrated in this smart grid, and so standardization is the must. Just to give you a glimpse of what all is involved in smart grid is starting from the generation, then transmission, automation, system coordination, system operations, energy efficiency, distributed generations. This is the new thing which is will be coming in the smart grid. There will be a lot of solar generation, wind generation, which needs to be integrated in the grid. And the appliances, smart appliances will have to be integrated. That's the, I will be talking further about that. And this requires strong sensing and advanced metering infrastructures. So how interoperability will help it makes it easy for consumers to use smart devices regardless of location and provider. Today, in our houses, whatever electricity is supplied at whatever fixed rate, we have to use that. We don't have any choice when to use or how to use it. But this smart grid, which will be integrated with the smart appliances, will provide control in the hand of consumer. It protects privacy while enabling consumer to securely access information on their own energy consumption. Today we get a bill at the end of the month, and we don't have any choice other than to pay for that bill. But in a smart grid, the consumer's involvement, the consumer will not only be called consumer, it will be called prosumer, means it will be producing and consuming in controlled way. It prevents premature obsolescence, which I already talked about, expands product market and promotes vendor competition. Interoperability is required for generating the competitions. And it should ensure, standardization ensures the security and enhances the reliability of the power grid. Fortunately, this subject of smart grid is being talked about since last 3-4 years, and many bodies are already working on that. IESA has been very active on that. They have identified a list of 300 standards to be upgraded to meet the requirements of the smart grid, and IST, IEEE, and various smart grid forums, including in India Smart Grid Forum is also working. Central Electricity Authority, Power Grid, they have also started working on the standardization for the smart grid. What is required for the interoperable communications? The data models has to be standardized so that it becomes interoperable. Protocols of communication should be standardized so that various devices, as we looked at in the smart grid, there are various stakeholders, and they will be using a variety of instruments and communication devices. So they should be able to talk with each other. It should be future upgradable. And also we need to see that whatever investment which we have already done in the grid or the electrical sector should not go waste. It should be integrable with the present system. There are various real-time applications which are important in smart grid, and they require time synchronization and also the redundancy. What are gaps in current standards? When we talk about smart grid and in the integrated grid, the gas and water meters also needs to be integrated, which are not done presently. Many wireless technologies which are coming up have not been standardized or are not part of the standards. IP version 6 has to be integrated. And there has to be a mapping between existing isolated domain standards. There are various standards for generation, there are various standards for transmission, for various standards for distribution. They needs to be integrated because now consumer will be involved at the grid level. This gives you how automatic meter reading, many of you might have heard about this automatic meter reading. Instead of meter reader going door to door, the meters can be read from the remote location. So this has been being practiced. It has been now upgraded to advanced metering infrastructure. In advanced metering infrastructure, the consumer is involved, demand response is there, theft detection is there, customer outage detection is there. So power goes in our house and it will be immediately or instantly visible to the distribution authority. So this has to be all compatible with the smart grid. So just to give you a picture of what is advanced metering infrastructure, there is a house which will have various appliances like air conditioners, geysers, and washing machines and lighting and all those things. And there will be a meter which is being called smart meter. All these appliances with the wireless technology will be talking to the smart meter, and smart meter will be talking to the smart grid. and will give you the informations, instantaneous information about the availability of power or rate of the power, which is now not fixed. It is varying hour to hour or maybe every half hour. So the consumer can decide when to use electricity, when it is cheaper. Why this is required? This is required because the present electrical industry is facing the problem of the peak demand. Everybody at present does not take into consideration what is the peak demand on the grid. So this meter will reduce the peak demand on the grid. So for example, the smart appliance which will be programmable, it can be, I can program that in the morning 4 o'clock my geyser will switch on and will keep the water ready, hot water ready for me for the morning, instead of I waking up at 6 o'clock and switching on the geyser. So that's how the peak demand which happens in the morning can be reduced. Automobiles will also be integrated. There will be electrical vehicles coming up. So automatic metering infrastructure consists of in-home display. So this in-home display, which is going to be a big requirement for the all the consumers will have to use this in-home display, which will give present all the information. Then an emitter and various communication devices and network management system. So this gives the overall picture of overall communications. This gives what will be this in-home display will be doing, and it will be talking. So this is about the home area network which will be required in the house. So key EMI requirements will be the metrology. The meters will be continuously talking to the grid and giving the information about the consumption to the utility. So lot of communications will have to be done. Prepaid meters will have to be integrated. Instead of paying later, the prepaid meters will be integrated like we pay for the mobile phones. So similar system will be there. Tamper detections, which is a big problem today for the distribution companies. So as soon as tampers, there will be sensors which will be detecting tampers and immediately informing to the distribution engineers, and they can take actions quickly. For the semiconductor industry, this is a big opportunity, at the same time big challenge. So power industry will be highly dependent on performance and reliability of the semiconductor components which will be used. This reliability will be very, very important because, for example, electricity meters and similar devices are the devices which need to work correctly, continuously 24 hours, 365 days. It's not like TV or any other semiconductor devices. Energy meter, because it is not the cost of energy meter, it is the cost of electricity which is lost by the distribution company, which is more important if a meter fails to operate. Thank you.